Hi, welcome to NewTech YouTube channel. In this video, we are going to study important theory on single-phase AC series circuits. Let's start. Now study some important key terms which are useful in understanding of single-phase AC series circuits. First key term, frequency statement. The number of cycles per second of a given waveform called as frequency. Refer the first diagram. One cycle occurs in 1 second means its frequency is 1 cycle per second or 1 Hz. Similarly, in second diagram, 2 cycles occurs in 1 second means frequency is 2 cycles per second or 2 Hz, where 1 Hz is equal to 1 cycle per second. Let's study second key term, period statement. The period of waveform is the duration of one cycle. Now refer the first diagram. The frequency is 1 cycle per second means the duration of each cycle is 1 second. Similarly, in second diagram, the frequency is 2 cycles per half second means the duration of each cycle is 0.25 second, where period is inverse of the frequency, that is period T is equal to 1 upon frequency f. Now study third key term, peak value statement. The peak value of a voltage or current is its maximum value with respect to 0. Refer the diagram. The peak value of the voltage waveform is Em, where amplitude is a distance from its average value to its peak value. Also, peak to peak voltage denoted by EPP. Up till now we have studied important key terms. Let's study sinusoidal AC voltage source, which is labeled with V. The voltage increases to positive peak amplitude, then decreases to 0, then changes the polarity and cycle repeats, where the waveform repeats itself at a regular interval called as the periodic waveform. Now during first half cycle, refer the figure 1. A resistor connected to an AC source. The source voltage is positive, therefore the current is in the clockwise direction. And at the second half cycle, refer the figure 2. The voltage polarity reverses means current is in counterclockwise direction. See the waveform of voltage and current in figure 3, where current is proportional to voltage and its shape is sinusoidal. Let's study generation of AC voltages. One way to generate AC voltage is to rotate a coil of wire at constant angular velocity in a fixed magnetic field, which is proportional to rate at which flux lines are cut, and it operates on Faraday's law. Refer the figure A. The coil sides are moving parallel to the field. No flux lines are being cut and induced voltage is 0. We are referring the coil position as 0 degree, which is also shown in a waveform at point A. Now refer the figure B. As coil rotates from 0 degree position, the voltage builds and reaches a peak when flux is cut at maximum rate. Refer this coil position as 90 degree. In waveform, the generated voltage shown by point B. Let's refer the figure C. The coil rotates further, then voltage decreases and reaches 0 value at coil position as 180 degree. In waveform, the generated voltage shown by point C. Then refer the figure D. As coil rotates, induced voltage reverses and reaches at peak, where coil position as 270 degree. In waveform, the same voltage shown by point D. Then further rotates the coil and we get position of a coil at a 0 degree, at which induced voltage is 0 and cycle repeats. Now study phasor representation of sinusoidal quantities, where phasor is a rotating vector whose projection on vertical axis used to represent sinusoidal varying quantities. Refer the diagram. Consider the red line of length Vm. The vertical projection of this line is Vm sin alpha, with phasor rotates at angular velocity omega in counterclockwise direction and alpha is equal to omega t. We get vertical projection V is equal to Vm sin omega t, and if we plot a graph of projection versus alpha, we get sine wave. Let's study phasor difference. Phasor difference is an angular displacement between different waveforms of same frequency. Refer the figure. For in phase condition, phase difference must be 0, and for phase leads or phase lags gives phase difference up to 90 degree. Now study resistive circuit. For purely resistive circuit, voltage and current are in phase. Refer the circuit diagram. The AC voltage source connected in series with a resistor gives voltage VR and current IR. The voltage and current represented with in phase condition with amplitude of current waveform is slightly lower than the voltage waveform. In phasor diagram, current magnitude IR and voltage magnitude VR shown on a real axis with zero phase difference. Let's see relation between voltage and current in resistive circuit as current IR is equal to voltage VR upon resistor R, which is equal to Vm sin omega t upon R, which is given by equation 1. Then current IR is equal to Vm upon R into sin omega t, which is equal to Im sin omega t, given by equation 2, where Im is equal to Vm upon R. Let's study inductive circuit. For purely inductive circuit, current lags voltage by 90 degree. Refer the circuit diagram. Thus, AC voltage source connected in series with inductor gives voltage VL and current IL. Voltage and current represented with 90 degree phase difference condition. In phasor diagram, current magnitude IL drawn on real axis with 90 degree lags gives voltage magnitude on imaginary axis. The relationship between voltage and current in inductive circuit is voltage VL is equal to inductor L into DIL by dt, which is equal to L di by dt into Im sin omega t, given by equation 1, with voltage VL is equal to omega L Im cos omega t, which is equal to Vm cos omega t, given by equation 2. We know cos omega t is equal to sin omega t plus 90 degree, which is a trigonometric identity. Now VL is equal to Vm sin omega t plus 90 degree, where Vm is equal to omega L into Im. Now study capacitive circuit. For purely capacitive circuit, current leads voltage by 90 degree. Refer the circuit diagram. The AC voltage source is connected in series with capacitor, gives voltage VC and current IC. Then the voltage and current represented with 90 degree phase difference condition. In phasor diagram, voltage magnitude VC drawn on real axis with 90 degree lead gives current magnitude on imaginary axis. Just a review, in this video we have studied important key terms: sinusoidal voltage source representation, generation of sinusoidal voltage with its phasor quantities. Then we studied resistive, inductive and capacitive circuits. Thanks for watching my YouTube channel. Thank you.